today we'll be looking at calculus because matrix will be soon writing. They will be soon writing their prelims. So we'll be looking at differentiation using the first principle or what we call the definition. So we will take an example of this. Remember, if you are asked to use the first principle or the definition, you cannot use any other method. You cannot use the general method. You have to use this method. However, you can use the general method to check your answer and then keep it by the side. And then when you are done, you can now check if you arrived at the same answer. So I'm going to do that. Remember the general rule? It says that the derivative of a function is, if we have this function, if we have a function a x to the power of n, the derivative of that function using the general rule is n times a into x n minus 1. So we will use this to check this and keep it by the side, and then after differentiating, we will see if we arrived at the same thing. Now, for this function, the derivative of the constant is 0. Then here we have negative, our n is 2 times the 1 here. So we have negative 2, and then x is 2 minus 1. So we have n times a, which is negative 1, that's 2 times negative 1, which is negative 2, and n minus 1, 2 minus 1. So this will give us negative 2 to the power, x to the power of 1. So after differentiating, this is what we are supposed to arrive at using the general method. So let's keep this by the side. So I know I'm going to arrive at negative 2 x as my final answer. That will be my final answer, negative 2x. So let's continue from there. Now, I know where I'm going to, so I can go on. Now, using the first principle, it says that the limit of the function will be the limit of f of x plus h minus f of x over h as h tends to 0. That is what will give us the first derivative of a function using the first principle. So what do we need to do? We have our f of x. So we need to go and get our f of x plus h. We need to get our f of x plus h. So how do we get our f of x plus h? Anywhere you see x, replace it with x plus h. So we will have 3 minus x plus h all squared. Let's simplify that and see what we get. 3 minus, if we do this distributive, this will give us x squared plus 2xh plus x squared. So this will be our f of x, which will plug into the equation. Don't worry, this will be given on the formula sheet. Just figure it out and then use it. Please note that notation is very important in this part. So we replace our f of x plus h, that's 3 minus x squared minus 2xh minus x squared. Remember that this negative belongs to everything in the bracket. Then minus our f of x. Please, it is a good practice to always put a bracket there so that you don't mess up the sign. So that you also understand that the minus belongs to everything on the other side. Then divided by h. Now, you have substituted everything. The only thing that is left is for us to simplify. Now, let's look at this. 3 minus 3 gone. Negative x squared minus minus is plus. So negative x squared plus x squared gone. We are left. Remember, you keep the notation until you have substituted the value to which h tends to. So over h. So as h tends to 0. So the next thing is to factorize, because we are still in the process of simplification. If we take out h here, we have negative 2x. If we take out here, we have 1. We have the limit of the function as h tends to 0 here. This can take out this. Now we can solve the value that h tends to into the whatever that is left of the simplified expression. If we solve in here, we have negative 2x minus 0. So the derivative of this function will be negative 2x. And we have used the first principle to differentiate this function. Now we have to compare this with our already established answer using the general method. You see, always do this. It is very, very, very useful because we are mere mortals. Along the way, one way or the other, you may have messed up a sign. But this will tell you that you are doing something right or that you may have done something wrong elsewhere, and then you can go back to check your signs. So this is differentiation using the first principle. Please remember to continue to share this video and continue to encourage your friends to subscribe. I will see you in the next video.